Hello, hi. Once again, welcome back to the series of OWASP Docker Top 10. As a series of this, we already covered till D08. Today, we are going to discuss about D09, that is following immutable paradigm. We are going to discuss what exactly the immutable paradigm and why immutable containers are secure, and some examples regarding real-time use case and some troubleshooting and recovery benefits and attack vectors for D09 and how the impact of image integrity is maintained, how to identify mutable containers and how to fix it after identifying. And after that, I just kind of a recap as well as some best practices. So without further ado, let's enter into the video and have a discussion around it. First thing was secure containers by making them unchangeable after the deployment. The core idea of D09 is to treat the containers as immutable. That means once they are deployed, they cannot be changed. This basically prevents the unauthorized modifications and keeps your environment predictable. And the second point was prevent runtime modifications that treat security vulnerabilities. Let's say if someone can change a containers at a runtime, like installing packages or editing the files, if it does it is like opening a door to a security risk, and they can perform some misconfigurations and even persistent malwares also. And the third point was essential practice for production Docker environments. In especially the production, immutability is the best practice. It ensures the consistency across the deployments, simplifies the debugging, and strengthen it will strengthen the security posture as well. And the last point was it's a part of WAP's top security recommendations for containers. Basically, the OWASP ranks this as a top priority for container security. Immutable containers reduces the attack surface, and that will make the infrastructure more resilient and secure. And moving further, now let us discuss what does immutable means uh, in container perspective with a simple definition. Okay, basically the immutable means cannot be changed or modified. Once something is created, it stays exactly the same. No edits, no updates, no surprises. And containers file system becomes read only after startup. When we apply this particular immutability to your containers, it means the file system in the containers will become only read mode. Once the container starts, you cannot like write in new files or change the existing files, and no files can be added or modified or deleted inside your containers. This will make sure that no one, whether it's a developer or any attacker, can make any changes while it was in your runtime. It is the best practice in the security. And like a sealed box, you cannot alter its content once it was closed. Uh, as a non-technical analogy, you can think like a immutable container is like a sealed box. Once it's packed and sealed, you cannot open it and change whatever inside existing. Uh, if you wanted to change, you need to build a new container or a new box you want. Okay. And here, as a non-technical example, I said no. You can think like a immutability is a DVD. Okay, which is only read. Uh, we can read whatever the data which is in the DVD. We cannot write. But mutable is USB. That means it is writable. The container should have like DVDs, especially in productions, that will lock down and remains unchangeable. Okay. And moving further, where we are going to discuss why immutable containers are secure. These are the some security benefits which are provided by the immutability. It will prevent the malware installation. Attackers cannot write the files. When containers are immutable, attackers cannot install malwares because it won't allow like write uh, options in the file system. This will basically blocks one of the most common attack vector, that is runtime compromise will be avoided. And the second point was stops configuration tampering. Settings stay unchanged. That means immutable containers lock down your configuration. No one can sneak in changes to the particular environment variables or any of the files like configuration files or runtime settings once the container is up and running. And the third point was eliminates a drift. Containers remains ideal to the original condition. Basically, the drift happens when the containers change over a time. With a immutable containers, every container stays identical to its same like original container, and making debugging as well as auditing uh, becomes much easier. Why? Because it is immutable. And the fourth point here was simplifies the compliance. That means easy to audit and verify. Immutable containers are predictable and very consistent. It makes it easier to pass the audits. It will verify the configuration and meet the compliance standards like PCI DSS or HIPAA, GDPR like that. And the final point was faster recovery. We just need to restart, no cleanup needed. Uh, let's say if something goes wrong, you don't need to clean up or patch the container. You just need to restart the particular container, and you will return to its original state. And you can also secure state instantly with these immutable containers. And here we are going to see some examples for D09 by using, I mean, some popular one was using read only and handling the updates. Now, let us see what is a good practice and what is a bad practice. The good practice was using a read-only container. That means we need to use, while running a Docker container, Docker run ---- read only and the container name. And the bad practice was writable containers. Defaultly, many like developers or DevOps team who are managing or running the containers, they used to use this particular command, Docker run nginx latest. This particular container runs with a writable permissions, and this means anyone or any process can modify the files, and that will breaks the immutable paradigm and introduces a new risk also. But here in the good practice case, it is a right way to run your container, especially in the production cases, by using ---- read only argument or flag that will make the container file system immutable manner, and no changes are allowed during the runtime. And the next point was builds updates, build new images. That means deploy, remove old. So when you need to make your changes, don't edit the existing running containers. Instead, rebuild the container with the existing image. That means new container, and deploy it and return the old one. This will basically keeps the environment clean and secure way. Temporary files. Use the TMP files and mounts for -tmp. Basically, -tmp was the root, like, or else the directory path where it was handling inside a container, and TMP file system is the file system in the host system. So if your app needs a temporary storage, we need to use a temporary file system mounts. This basically creates in-memory file system that cannot persist or affect the container's immutability. And the final point was logs. That means write to volumes, not a container file system. Basically, this is also one of the best practice for maintaining logs. Always we need to make sure to write to a external volumes or some logging drivers. Never write a logs to uh, a, a file system which is inside a containers. So it should remain untouched. That means we need to use the host file system. That is the point here. And now we are going to see some troubleshooting and recovery benefits, how immutability simplifies the operations. So the first point was it will be predictable behavior. The containers always start with the same way. So immutable containers behave the same way each and every time they start. No hidden charge, no hidden changes or no surprises. It is just consistent and predictable execution will be happened. And the second point was easy to roll back. Whenever we deploy a previous working images, then the rollback will becomes very easy. If something breaks out, we know we don't need to fix it. Like we just need to redeploy a previous working image, and you are back to a business, and no patching or no debugging under pressure. And the third point was no configuration drifts. And the third point was configuration drifts. Eliminates it. It will eliminates it works on my mission. Basically, what exactly here was immutability kills the classic executions. It works on my mission that problems since the container don't change after the deployments. There is no drift between the environments or any configurations. And the fourth point here was faster recovery. Restart container instead of debugging. When the container misbehaves or you don't waste time on like debugging or troubleshooting and making a changes in your runtime, we just need to restart that particular container and it resets to its original state and clean state file will be maintained. The final point here was simplified debugging. That means issues are in code, not in a runtime changes. Whenever the immutable containers, you whenever the containers you run as a immutability, you can easily debug the issue and you can know like where exactly the issue is happening and uh, you may the debugging will become simplified manner. And next, we are going to see some attack vectors. What hackers do with a writable containers. So these are the some popular attack vectors for D09. So the first one was install backdoors. That means it will provide a persistent access tools. Uh, Especially the writable containers allow a attackers to install a backdoors tools that will basically give them a ongoing access when uh, even let's say if we perform a reboot also. Uh, this is very hard to detect and it is also can be used to control your entire host system remotely. The second point was planting cryptocurrency miners. That means it will steal the computing resources. uh, they will like deploy a crypto miners inside a writable containers and those basically what it does was it will silently consumes the entire system resources like cpu memory or process and your like other systems will slow down and your app may not respond which is running inside the container. The third point was third attack vector was modify the system binaries. That means it will hide the malicious activities. We are not going to know like what exactly happening behind the scenes. Attackers can alter the system binaries like a top nestat and they can use some linux powerful capabilities and that will makes it very hard to identify the issue also and we not even know like such kind of activity was done in the backend. And the fourth attack vector was change configuration. That means display security features. Especially the writable containers let the attackers to change your configuration files and disable your firewalls or else to turn off the logging mechanism. It will make it very easier to operate undetected. And the fifth attack vector was store stolen data. Basically, they use the containers to temporary as a temporary storage. That means uh, if the container is a writable and whatever the data which is attackers have to store as a temporary and they use this particular container and they consume all the resources and storage and they use this as a temporary and there might be a sensitive information also. Okay, and here real attack vector real attack was hackers modified uh, like a powerful file that is etc hyphen password to create a new admin users. uh, Especially this can happen in a real world where they can edit a sensitive files which is dot slash etc and password. Basically they can edit the admin users in that particular file. Okay, and that will get you full access to the host file system. Okay, now we are going to discuss about impact of ignoring the immutability. What are the some consequences of mutable containers? That means, okay, the first we will be discussing some points regarding the security risk. After that, some operational issues also. So the first point here was the data breaches will happen. The sensitive information will be or maybe stolen. Especially the writable containers can be exploited to a that there is a possibility to store the sensitive data like credentials or some tokens or some any records which is stored and that will lead to a data breaches and that is very much serious concern and that will damage the reputation also. And the second security risk was hidden malwares. That means undetected malicious softwares. Attackers can install some malicious softwares with hiding inside your containers. Okay, so since the file system in the docker container is editable or writable, then they can edit and without noticing, they can make a changes or install some malicious softwares in the backend. The third security risk was privilege escalations. That means attackers gaining a admin access like that. Uh, I mean, whenever you have a writable permissions to a file system, they can edit. Earlier we have seen slash etc and password file like that. Okay, so they can change a permissions and they can like gain a more like permissions what they need, or else uh, they can get a admin access or a host file system also. Okay, and here are the some operational issues. The first one was configuration drift. That means it is in inconsistent environment. Okay, when the containers can be changed after your deployment, they can drift from their original state. This basically causes a inconsistency across the, let's say, dev environment, testing environment, or production environment. Okay, so configuration drift may happen. And the second operational issue was complex to debug. That means unknown system data like that. Okay, uh, basically the mutable containers create a unpredictable system states. So that is the reason why it becomes complex to debug. The third operational risk was compliance failure, especially the audit trail lost. Okay, so without immutability, it's hard to maintain a like reliable compliance as per the regulatory bodies, and that will leads to a compliance failure, and that will fail the security assessments also. Okay, and moving further, where we will be discussing about how to identify a immutable container and later, sorry, mutable container, and later how to fix the mutable containers, what like changes or actions we need to take against it. So these are the some detection methods. First one was we need to check Docker run command. If it is missing hyphen hyphen read only, then it should be like flagged there. Okay, so first thing was we need to review hyphen hyphen read only flag, which is uh, while running a container, we need to make sure to use this particular flag, especially in the production environments. And the second like detection method was inspect running containers. That means we need to verify randomly uh, rootfs, root file system settings. What it does was by using a Docker inspect uh, to check if the container's root file system is read only, we are going to look for the randomly root fs, that means file system settings. It should be set as a true. Okay, so the third method was monitor file changes. That means it will detect your runtime modifications. We need to use some monitoring tools to track your file changes inside your container. If the files are being added or modified or deleted during the runtime, the container is mutable. Okay, it's not immutable, it's a mutable container. Okay, so that is also one of the method. And the fourth like detection method was we need to review the Docker file. Look for unnecessary write permissions. Sometimes you may see the permissions which is actually not required, but it was present in the Docker file. Okay, so by scanning your Docker file for commands that will uh, creating some unknown paths or installing some unrequired packages in the runtime, these can break the immutability and introduces the risk. So that is the reason why we need to review the Docker file. And here is a command to check whether the read-only root file system is true or not. Okay, so Docker inspect and container name pipe grep read-only file system. So it should return true. Okay, if it is false, then we need to make sure it was a mutable. Okay, and here we are going to discuss how to fix and prevent whatever the things we have earlier identified. We need to see like what are the ways to prevent them. Okay, and most of the solutions already we have covered earlier slide only, where the first one was we need to make sure hyphen hyphen read only flag. We need to add this flag in a Docker container, sorry, Docker command whenever we are running a container. Okay, so it will basically locks the file system and it will enforces the immutability at runtime. And the second one was use a temporary file system mounts for temporary files like hyphen temp var run like this. Okay, basically what exactly it was, if your app needs temporary storage, we need to use a temporary file system mounts, tmpfs. So these are in-memory file systems and that cannot I mean that don't persistent and don't break the immutability also. And the third fix or prevention method was external volumes for persistent data. By using the external volumes for data that needs to be saved, like some databases or some uploads, we need to use the external volumes. It will keep the container itself clean and a stateless manner. Okay. And the fourth like prevention method was log to external systems, not a container file system. That means send all your logs to a external system, like some ELK stack or some cloud logging service that will avoid the writing logs inside a container. It should remain untouched. Okay. And the final point was test thoroughly, ensure app works read only. Before you are going into your live, test your application in a read only container. Make sure it doesn't try to write to the file system or crashes due to some misconfigurations or permissions. Okay. So that is the some prevention steps you need to follow. And here is the one example command. This command runs a Nginx with a read only file system and a temporary -temp amount. It's a very secure and it is very much suggestible in production ready setups. Okay, here is the command docker run --- read only and -tmpfs -tmp, and this is the container name and tag. And finally, we are almost at the end where we are going to see some best practices and recap of this, and also some key takeaways. That means what exactly we have till now discussed. So here is some core principles as well as the remember points we are going to discuss. The core principle was we need to make sure to rebuild, don't patch the existing container, create a new like images instead of that. Okay, so if you need any changes or you need to make sure to rebuild and redeploy that, this basically keeps the environment clean and secure manner. Okay, data stays outside. That means we need to use the persistent volumes. So it will basically stores the data in the external volumes, so the container itself remains immutable. And as we always know, we need to make sure to use a --- read only tag in a production whenever we are running the container. Okay, and these are the some uh, like remember points regarding the Docker security all the time. Security, you need to make it by design. Prevent, don't detect. Okay, so immutability is about prevention. So don't it's not about detection. So log things down so the contain I mean so the attackers cannot even start their job. Okay, and consistency matters. Same behavior everywhere. Okay, immutable containers behave the same in the different environments like dev, test, production. So this consistency makes easier to debug and scale to a wider range whenever it is possible. Okay, and also it is easy, okay, to scale also and debug also. And the final point was simplify operations. Restart over repair. That means if something is breaks, we just need to restart the container and no need to repair or debug the like running container and make the changes in the runtime. It basically resets a clean state if you restart uh, the container. Okay, and yeah, that's it. I think whatever you spend time for learning, it is worth. And we just may, I mean, pending with the last one, which is D09, will be discussed in upcoming video. And yeah, stay tuned for more videos. Thank you so much.